your point, you're saying this. You're saying differentiate with respect to x 3x, I get 3, but actually multiply the derivative with respect to x of something else. But I think this is the last function in terms of x. That's the innermost function I have in this particular nasty business, which is composition of several functions. Since the last innermost function is 3s, once I differentiate that, I think I'm done. Because if you continue that further, then you're going to be multiplying by 0, which means everything is equal to 0.
Oh,
You see my point?
gotcha.
If that is okay, what about something like number 65? Oh, it's not here. Damped oscillator, got it. Yikes. So I want to consider the function y being equal to 10, e to the negative t halves, times the cosine of pi t over 8. You guys, do we have to do this? I mean, this is kind of a silly question, isn't it? Can I just skip it? I mean, it doesn't really have any meaningful interpretation in real life.
Sure, let's do it.
It's a trap. Why is it a trap? Why? Why is it a trap?
It doesn't show up on the test.
No, that's not why. Is this a realistic function?
No.
It's complicated, so probably.
That's a good response.
Well, it has natural log in it, so it probably does.
What does that look like?
Cosine pi.
No, use words. Use words.
Sinusoidal.
Sinusoidal wave, which is simple harmonic motion. It's just the amplitude, oh shoot, is no longer constant. It's almost as if, here's the t-axis, here's the y-axis. It's almost as if this is 10, I've got a cosine wave whose amplitude is dominated by some exponential curve, which is y equals 10 times e to the negative t halves, or from below, y equals negative 10 e to the negative t over 2. Have you ever seen this before? When you came into the college this morning, or this afternoon, this evening?
What?
When you turned on your radio, and if you have AM station, AM stands for, oh my gosh. Did I walk in the right class?
Nobody has radio anymore.
AM stands for amplitude modulation, where a sinusoidal wave, a sound wave, is being enveloped by some other cosine wave or sine wave, that doesn't care which. This is a signal. Until, World War II, the Americans got pissed off because they couldn't keep track of the signal, and so they developed what they call the superheterodyne radio, which modulated in terms of frequency instead of amplitude. Well, actually, it's different than this, but amplitude modulation is similar to this. Here, my amplitude is just being dominated by the exponential function sitting right here in the coefficients position. You see this whenever you
Turn on the radio.
not anymore because these aren't cosine wave modulated. But like when you pull a spring down, let go, it kind of oscillates back and forth, but eventually the oscillation decreases over time. And so bottom line is, this is an example of what we call damped harmonic motion, where maybe like a spring, the vertical displacement from the natural position is decreasing over time. This is what mathematical models say. Pops up all over the place in applications. And I haven't even discussed. Yeah, it is important. And I haven't even discussed the question. I'm sorry. I'll come back.
You did
Graphical displacement function. Oh, I just did. Well, actually, I didn't. Where do you think this tick is right here?
Pi over 8.
Where?
Not pi over 8.
No. Where's this tick?
Pi.
I feel so alone.
2 pi.
Isn't it like 2 over pi over 8?
Or better yet. Oh, you guys are killing me.
Pi over 2.
16.
Thank you. Thank you. Thank you. Because 2 pi divided by that coefficient is nothing more than 16. So that's where one full cycle the cosine wave stops. Ooh, that was rough.
Oh, nice.
How about something like part B, compute and graph the velocity of the mass. Well, if I'm gonna compute the velocity, I think the velocity is gonna be nothing more than the derivative of the position. Ah, but shoot, you guys, check this out. Is that a negative 1/2? Times 10 to e to the negative t times negative sine of pi t over 8 times pi over 8.
That'd be negative 3t halves. Then you just subtract line.
No, because I'm not differentiating a power expression, I'm differentiating the exponential expression. So you guys, what's going on next Wednesday? You always test, so question, is that okay? I'll say it again. Next Wednesday we have a test, so is that okay?
No.
No.
Why not?
Simplify.
Worse. I think everything on the board is completely erroneous.
Yeah.
Why? Why? Forgot to,
Product rule, right?
thank you.
Yeah.
The whole point is when I differentiate the product of two functions of t, I have to use a product rule. Do you guys see my point? All right, let's try that again. If I'm going to differentiate the product of those two functions, I think I get, I don't know, the first times the derivative of the second
Negative sine
Pi over t.
times pi over 8.
The chain rule says I got to multiply by the pi over 8, which is the derivative of the innermost function. Plus the product rule says,
The first question.
we mean the second function sine,
Oh.
which is the cosine of, I forget, is that pi t over 8? Times
Derivative of the first.
the derivative of the first, which is 10e to the negative t over 2 times of
1/2.
say it again.
Negative 1/2.
Negative 1/2. Very nice. I agree completely. Oh, actually, do you guys think we can come in and clean this mess up?
Oh yeah.
How? What are you gonna pull out?
Multiply the 1/2 to the 10, giving you the negative 5.
Where's that? I'm sorry.
Negative 1/2 times the 10. That's the very first function.
Oh, so you want to simplify first. Got it.
Oh.
So you want to rewrite each of these as, is that a 5/4? That's negative e to the negative t halves? Sine of pi t eighths?
That just becomes ugly.
This is what you told me to do. Plus.
That's so not the way that.
Minus, I don't know. is
I
that
was
five?
joking. I was kidding. Take it back. Take it back.
e to the negative t halves, cosine of pi t eighths. Ah, I can't read my own writing. Hold on. I said pi t over 8. What should we do next?
Did you lose?
That was a question for you to answer. What would we do next?
Did you multiply pi 8 times 10, right? Wouldn't there still be a pi that multiplied to the negative?
Sir, that's my mistake. I did not mean to intend that. You're absolutely correct. My apologies. I forgot that lingering factor. I really did.
Pull out e.
Okay, I think we should pull out a factor of e to the negative t halves. It's in common as a factor for both those two terms. You guys, help me. What else?
Pull out a 5, negative
I can
5,
pull out a 5 or negative 5. What else?
and
What else?
1/4.
Very nice. Let's talk about what we're standing as remaining factors on either side of the addition operation. I think on the left-hand side, if I pull out a negative 5/4, as well as the e to the negative 2t over 2, I think the only thing left over is the sine of
Pi
pi.
t over 8.
Okay, pi.
Yeah, what about pi?
Oh, I did forget the pi, didn't I? Jeepers. What else from the left-hand side, or from the right-hand side?
Cosine times t.
The cosine of
Pi t.
pi t over 8. What else?
1/4.
I can
Oh,
hear you.
yeah.
A positive 4. I agree.
Yeah.
Looks nice.
So that's so not the answer that the book got, or I got. That's the same one I got right here. That's how I did it, but I ended up with the book answer.
Oh, so the author didn't pull out a 1/4. I disagree.
Okay.
That's the Actually, I disagree with both the author and my answer. Is Is that a sinusoidal wave?
Yes, absolutely.
Then what's its amplitude?
The 5, 4, negative 5, 4.
See, I think it's positive 5 quarters times the square root of pi squared plus 4 squared?
What?
No? Yes? No? You guys see this sinusoidal wave?
Not in my head. It's,
Oh.
we don't have the matrix in our heads.
How many of you are engineering majors? I will not embarrass you with the question. That's what I'm doing. Can you think one more time? You of us are engineering majors? Holy cow. Same thing?
No,
What do you mean, what? What did I do wrong?
you have to multiply by 1 over square root.
I feel like
Oh, okay, so I blew it. Technically speaking, I multiply everything by 1 over square root of the junk. That's not legal. To compensate, I'll multiply by square root of junk. And at least in the end, what I've really done is I just multiply by something with the form of 1. Do you guys agree?
Yes, why'd you do that though?
Here's why. Because I think, if I drew myself a nifty little picture with an angle phi, it better than a right triangle. And, you guys, I'm sorry I'm so slow, hold on a second. If I thought of the adjacent side to phi to be as 4, and this to be a 5, pi, wouldn't the hypotenuse be this? So don't you guys agree that what you see over there, which is negative 5 quarters, times the square root of pi squared plus 16, you guys, I can't read the rest, I'm sorry, I'm too far away. Is that e to the,
Negative t over 2.
thank you. And is it being multiplied by,
pi.
is that cosine of, jeepers, cosine of pi t over 8? Times 4 over root junk, which is nothing more than cosine of phi. Plus, that first term, which is nothing more than sine of pi t over 8. Times, oh shoot, that coefficient, but look at my picture, it's not just simply the sine of phi. Or shall I say, this is nothing more than negative 5 quarters times the square root of pi squared plus 16. Times e to that nasty looking power, times oh shoot, look at that. Using your subtraction identity. Come on, you guys, for the cosine function.
Oh, yeah.
Isn't that just simply the cosine? Ay, ay, ay. Of nothing more than pi t over 8
Alpha plus beta.
minus phi. Thank you. I hope that wasn't sarcastic. And that being the case, you know, without the change here, that's a kind of sinusoidal wave. And we can talk about the amplitude. What? No, really? I mean, whenever you got a sine of something plus a cosine of something, you can always manipulate those coefficients to use the addition or subtraction angle identity for either the sine or cosine function to make it look prettier.
I'm okay with that.
That's what I did there, yes.
What's phi?
Phi is just something I made out of thin air to represent a relationship
Oh, it's
between
over
pi and
there.
4.
Oh, I see.
Okay, never mind.
So it's not on the test.
What about number 39? You guys just don't want to play.
Oh, I still got the final answer
What's that?
for 65. There's part C.
Oh, did I miss something? I'm
Yeah.
so sorry. You guys, I never answered the question. Hold it, let me come back. So part C, verify the velocity is 0 when the mass reaches the high and low points of oscillation. guys help me for this. Help me with this. For what value of t does that occur?
1.
I can't hear it.
Oh.
For what value of t does that occur? You guys, I'm not making any mistakes, but you know what? It's getting confusing. Can I change color real quick? I won't change anything in row, but let me do some blue. You said at t equals 0, I attain my maximum height. At t equals 8, I attain a local min. And I think here, this t value is going to be,
16.
I'm not answering the question yet. I want you to look at my picture. What do you think the slope of the tangent line is at those 3 values of t? What does it look like it should be?
0.
I think so. Let's see if it's true. Did I compute the derivative function? Oh, here it is. And if t is equal to 0, what's the sign of 0?
0.
Is this a derivative function? It is. So the sign of 0 is just going to be 0. But over here I get 1. And here I get e to the negative 1/2. They just want you to divide all this garbage on t is equal to 0 and see what you get. That's all they want you to do. Nothing more. Yes? No?
They should write it in there, evaluate the garbage.
Attack the garbage,
This-
right?
They use a bunch of terminology like, what?
Yeah. That's all they want. Nothing more. Yikes! 39? Aha. So somebody's given me that y is equal to this nasty business.
Is that a 3 or a 2x?
That's a 3x. Aren't you glad I typed your exams? So, if I were to differentiate, you guys help me with this. I mean, come on. What's the term of the sine function? What's the term of sine of x?
Cosine.
I can't hear it.
Cosine of x.
I can't hear it.
You shouldn't have to.
It's
Well,
irrelevant.
yeah.
What do I do first?
You're gonna bring the 5 down in front.
Beautiful. I'm going to differentiate something to the 5th power first. And I think if something is raised to the 5th power to differentiate, I get 5 times that darn thing raised to the
4th power.
and nothing else changes yet. However, the chain rule says I got to multiply by the derivative with respect to x of whatever the heck I was initially taking to the 5th power, which in this particular case is
The sine
the sine of
of cosine
the
3x.
cosine of
3x.
3x. Do you guys agree with me? Ooh, Steve, you don't. Steve, check this out. Don't look what's in here. I think whatever goes in my parentheses is going to be, well, whatever the heck was being raised to the 5th power, which is a previous function I differentiated. Since the previous function I differentiated was something raised to the 5th power, whatever was raised to the 5th power is exactly what goes in here. So just go back to the previous, differentiation process. Since I differentiated something to the 5th power to get this garbage, then the question is, what was being raised to the 5th power? And that's exactly what goes inside this set of parentheses. As a matter of fact, using my same logic, my same language, I've got garbage. Let's differentiate. So the derivative of the cosine is,
Negative sign.
derivative of the cosine is,
Negative sign.
cosine is
Doesn't matter.
irrelevant. I got to differentiate. I got to differentiate the sine function because that's the outermost function. And the differential sign of anything I get, the cosine of that garbage. And so I think I got to multiply by the cosine of whatever the heck that garbage is, but humor me. What function did I just differentiate? The sine function. The chain rule says I got to differentiate with respect to x by of whatever the heck I was taking the sine of, which in this case is,
Cosine of 3x.
I agree. Aw, shoot, let's keep rolling with this. I guess that gives me 5 sine to the 4th of stuff times cosine of, stuff. Times, let's differentiate. To differentiate 3 of x, what do you get?
3.
You get,
3.
you get,
Irrelevant.
irrelevant, you gotta differentiate the outermost function first, which is
Negative sign.
differentiate cosine of some stuff, which is a negative sign of that stuff. Do you guys see my point? I'm not trying to irritate you.
Yeah.
Oh,
Times
shoot.
3.
This is not good enough. I gotta multiply by the derivative with respect to x. I'm just showing steps.
3x.
Of whatever the heck I was initially taking the cosine of. Ah, but shoot. That just gives me 5 sine to the 4th of stuff times the cosine of stuff times the negative sine of 3x times the yeah, I agree. You insist on applying the chain rule again? Fine, you're gonna multiply by the derivative with respect to x of x, but that's just simply 1. Is that okay, you guys? I think I'm sloppy.
You could multiply
Yeah, I would
3
have
by
brought
the
the
5.
coefficients up front, cleaned up a little bit.
Negative
But
up
the point
front.
is, I applied the chain rule repeatedly successfully. Will you do that again next Wednesday? Okay.
Why not?
Why not?
Don't have much straight to it.
Always have a choice.
Oh, you always have a choice. You don't have to take the exam. It's not mandatory. Yikes, you guys! What's next? 25? Hoi.
I have a quick question.
Yes, sir.
On 39, the
Yes.
back of the book has got a negative.
And I,
So you can pull out all the way out front?
yeah, as a matter of fact, to write this more simplistically, I would have done this. Watch my white rags, blue pen. Here's a coefficient. Here's a coefficient. Here's a coefficient. I would have pulled them all up front.
Okay, got it.
I think I probably would have written this next.
Why?
It's shorter. It's more concise. I would have written this factor next.
Oh, I see.
I would have written the original one, or the one up front next. It looks nicer.
Is that the proper mathematical etiquette?
What's that?
Is that the proper mathematical
I
etiquette?
hate to say it that much. For me, yes.
Okay.
I like more simplistic factors up front, but it's not necessary. How did the author write his answer? Does anybody know? Did he write it in this order? I never look at the answers in the back of the books. Yes.
You wrote it like this.
Okay, slightly different order, but same answer.
Yeah.
Isn't it? You see it. So can I move on? So where am I at? 39. Oh, I'm sorry, I did 39. What about number 25? So theta squared secant of 5 theta. Theta squared secant of 5 theta. Theta squared secant of 5 theta.
Yeah,
To use the version 2 rule of that U substitution stuff in the book,
The use of.
when they're taking one of the derivatives, U to the squared or whatever it is.
Are we gonna need to know both versions for the exam?
They ask you to use version 1, and then they ask you to use version 2, and then they go into stuff like this, where it's just a chain rule. Version 2 is just the regular chain rule. It's not the use of.
You guys, I'm at a loss. What do you mean version 1 and version 2?
Oh, they have both versions and they're the same thing. They're just written. One's written with dy dx. The other one's written with f prime and g prime.
It's problem 1, I think, is what it's.
It's right at the very beginning of chapter 3. They have.
I'm getting there.
Is there a simpler way to do this without knowing all these? Is there one version that does it all? Or we have to know
Absolutely,
all these?
emphatically yes.
Okay.
Emphatically yes. Do you guys mind? Besides that, I think in question number 25, it's not just the chain rule, it's also the, I think it's product rule as well. In fact, I think it's the most complex portion of this. So let me show you what I would do. To differentiate, y with respect to theta, I think I got the product of two functions. And the product rule says to differentiate, I get the first as is times the derivative with respect to theta of the second, plus the second as is, times the derivative with respect to theta of the first. Let's do it. That gives me theta squared times, I got an idea. Don't look at the input over here. How do you differentiate secant of anything? You get the secant of that thing times the tangent of the thing. Am I done? What do you mean, no, why not? Where'd you get 5? Well, the chain rule says I gotta multiply this by the derivative with respect to theta of whatever the heck I was initially taking the secant of. Do you guys see my point? Plus the secant of 5 theta times, I'll be quiet.
2 theta.
Is that the chain rule?
Power rule.
No, it's just a power rule. However, with the last differentiation process, differentiating 5 theta respect to theta gives me
5.
5. Don't you think that answer looks pretty?
Oh, yeah.
No, you don't. You'd rather.
Factor out
Factor
the
out
secant of 5
Secant of 5
theta.
theta and theta as well. I think it would look so much nicer as theta times the secant of theta times what the heck is left over. And on the left-hand side of the addition operation, I think the remaining factors that remain standing when I pull that garbage out is
5 theta.
5 theta
Tangent of
Tangent
5
of
theta.
plus,
Theta.
I can't hear you.
Or 2. Yeah.
Why would you take out secant of 5 theta?
Why would I or would I not?
Why didn't you?
He didn't write it right.
I did, I just didn't write it as such, thank you. I agree with you completely. That was my mistake. Are you happier? Yeah, how much that beats
I'm
me?
just,
It's gonna increase that bound.
I just remembered, like, my old teacher used to tell me back in high school, he was a physics teacher, he said that a teacher should only be able to make 3 mistakes in a term or a year, otherwise he's called an idiot.
Oh, I'm an idiot on a nightly basis then. But they're just arithmetic errors.
Yeah.
Is that okay, guys?
Yeah.
How about something like 37? Aha. Oh. That looks kind of awkward when you ask a question. Calculate the derivative of the following. Dang it. I am failing my job so miserably. I'm supposed to be writing a list of all the irritating things about this book. I don't have enough time. You guys, seriously. If I'm asked to calculate the root of this function, what do you think I'd say? That you don't answer the question, you get full credit. It's not a function, is it? A function is a process. A function is a rule. This is nothing more than the output of a function when the input is x. So the author is really, really misstating things. He meant to say this. If f of x is equal to this, compute the derivative of
F of x.
The garbage.
f. That's the function. Did you guys see that point? That's what he really meant to ask. So, if I were to differentiate, well, I guess f prime of x, that is the output of the derivative function, is going to be, I don't know, what's the derivative of the cotangent function?
You don't have to yet.
When?
Yeah, you have to bring down.
Thank you. Since the squaring function is outermost function, I think it's the first function I should differentiate. But to differentiate rid of anything, what do you get?
1
1 over 2
Over
root of
2
that
to,
thing. And so I think f prime of x is gonna be 1 over 2 root of that thing. Ah, we can't do this. 1 over 2 root of that thing. But I gotta multiply by the derivative with respect to x of the square root of the stuff. What's next? What's next?
Wait,
Why is there?
why is there a root there?
So next is use my eraser. Do you guys see my point?
Yeah.
I've already differentiated the square root of a function. I want to multiply the derivative with respect to x of what the heck I was taking the square root of. There should be no square rooting in there, should there?
No, definitely not.
Okay, let's keep going on that. I guess that's 1 over 2 root stuff. No tricks here. But if I'm going to differentiate 1 plus cotangent squared of x, what's the root of 1?
0.
Done. What's the root of the cotangent of x?
you don't need to yet.
It's irrelevant. I got to first differentiate
You gotta bring down the square.
squaring function. And to differentiate something squared, I bring the 2 down.
Yep.
Reduce my exponent by 1. But the chain rule says I gotta multiply by the derivative with respect to x of, I don't know, whatever I was initially taking the square root of,
Cotangent of x.
which is a cotangent of x. Well, you know, you guys, look inside the parentheses. That's simply one function in x. There's no composition. I think we're done with the next step. I think I have, fraction times 2 times the cotangent of x and times, well, let's compute.
Negative cosecant
Sorry,
squared of
I was gonna write
x.
secant, sorry,
Negative cosecant.
my mistake. So negative cosecant of x.
Squared of x, right?
Yes.
Thank you, I agree completely. Or by the way, canceling some 2's, so give me, I don't know, what is it?
Cotangent x, negative cosecant squared x over
So
square root.
negative cotangent of x times cosecant
Square root.
square root of x all over.
Square root of 1 plus cotangent squared.
Be happy. They cancel. No, you never answer my question. Is everybody happy?
Well, there's
Yeah.
a radical in denominator.
Oh, there's a radical in the denominator, but the book doesn't care about that.
The book left it.
Whoa, back up for a minute. Is this the answer in the back of the book?
Yes, that's the answer in the back
No,
of the book.
show me.
Seriously, I'll show you.
That can't be true, no.
260.
I wanna go home. Let's do it. Number one, I asked you what to do. You should have told me never to go through any of this garbage. This is way too much work. Secondly, if I go through all this garbage, I just checked. That's the answer in the back of the book. This is by far, completely erroneous. I misspoke. It's not erroneous. It's not simplified at all. I mean, using your Pythagorean identity, using your third Pythagorean identity, what's the heck is another name for 1 plus cotangent squared of x?
Cosecant.
Cosecant.
Yeah, I agree. It's just if you take the square root of it, what do you get?
Cosecant squared. Or just
Cosecant.
And if you cancel, what do you get?
Negative cotangent x times cosecant x.
The author necessarily should have simplified the answer to that. Secondly, I would never do any of this. I'm not wrong, I just think it's way too much work. Can I show you in one step what the answer is?
Please.
F of x is equal to the square root of 1 plus cotangent squared of x. Ah, but shoot, no calculus. 1 plus cotangent squared of x is
Cosecant
cosecant squared
of
of
x.
x, but the square root of that is
Cosecant of x.
cosecant of x, so I think its derivative is for free, negative cosecant of x times the tan, excuse me, I misspoke, cotangent of x. Do you guys see my point?
Yes.
How do you get the cosecant square on top?
I got that from this factor right here, which was created by differentiating the cotangent of x. Because the cotangent of x is negative cosecant of x. Do you guys see my point? Always apply your Math D or Math 8 skills first, before you apply the calculus. I could have saved all that work, it's just a one-liner. Okay. Do you agree with me? All right, as long as you agree. Okay. You're not gonna listen to me anymore. Where am I at? 31E. hold it, guys, I gotta make sure I wrote down the right symbols. Just a minute. So f of g, good, I got it. So, what can you say about h prime of x? F prime of g of x times g prime of x. Oh, you know, I misspoke, I'm sorry. I meant to ask, what's h prime of
5.
You said 5? Well, wouldn't that be this? Which, by the way, is f prime of something, times something. Oh, but shoot, looking at this table, I think g of 5 is nothing more than... I think g prime of 5, they gave me automatically is nothing more than... It's just that f prime of 2, according to this table, ends up being nothing more than 2. And so I think at the end, I just simply get it. If you don't have your text with you, I'm simply grabbing these numbers from a table. Just write this down and go back and check your book. I think so. Please. It was going to shake me up on this. How about something like 43? Ooh, that's too cool. So root x plus root x. I want a yes or no answer. Is that red operation the outermost function? I agree. And I can differentiate the red outermost function. I get 1 over 2 times root of that stuff. It's just the chain rule says I got to multiply by the derivative with respect to x of root x.
Why are you, what about x plus root x?
What's that?
Wouldn't it be x plus root x?
Why are you saying that?
Well, because that's g of x.
Everybody, I'm 100% incorrect.
Yeah.
My point is this. Since I differentiate the red function, I did it correctly here. It's just a chain rule says I got to multiply by the derivative of what the heck I was redly taking the square root of. That's the innermost function, or the next innermost function. Do you guys agree? Alright, I'll clean up my nasty looking mistake. I think I need to multiply this by the derivative with respect to x of whatever the heck I was redly taking the square root of, which really is all this garbage. I think that makes a big difference. Let's do it. To differentiate with respect to x, x plus root x, what do I get?
1 plus 1 over 2 root x?
I want a yes or no answer, am I done?
No.
Oh, why not?
You could just combine the two.
Oh, no,
And
you're
then-
right, I can clean up, I'm sorry, I misspoke. Am I finished with my calculus?
According to the
Yeah,
book,
I
I
think
think
I
you're
am.
finished with the
And you
entire
guys suggest
equation.
I need to pick up my math deep room and clean up a little bit, that's fine. I can do that.
I think the book just left it like that.
Yeah,
too.
Don't tell me these
I'm
things!
serious. I cleaned it up, but
That looks awful, he should never do that.
We should not support it.
What's that?
We should not support his book then.
Yeah, he's making too much money, isn't he? I mean, come on, you guys, that's not look more aesthetically pleasing to the eye. So, just say yes. Any questions? All right. Do you guys think you can show me what you got? Please.